Today we're going to solve this question, minimum limit of balls in a bag. I've seen a lot of videos. It's kind of boring. Literally, when they try to explain the question, I'm really fell asleep. So I'm going to tell you in a very simple way what this question wants from us. So basically, guys, you are totally bored with the description already. So I'm going to tell you what this question wants. So let's say we have an array of nums. As you can see now, right at this place, this is 9. So, the length of the num basically decides number of bag. And since we have only one bag, which means it contains 9 balls in it. So operation is something which basically means that we can divide a bag into two bags. Let's say in this we can divide into this and this 4 and 5, and there could be another possibility in another parallel universe or whatever. We can also divide this into this. So basically, for right now, we just did one operation. For this possibility and for this possibility. The next two we can do, there is another operation since we have maximum operations of two. So which means that we can basically divide this into two, comma two. This could be, we could do operation over this of 5, but we picked this one anyways. So in the end, we got this. And on the other universe, we could also do the possibility in which we're gonna pick this and do the operation mentioned by the quotient itself as right over this place. It's the thing which I'm doing basically the same thing. You don't need to go through it. If you want to, you can, but it's all the same. So yeah, then it is will become like this and 3 comma 3, and this will be the resultant answer. So out of these, the question want us to get the maximum number of balls, and you want to minimize it. So basically, it's kind of confusing. They're telling maximum and minimum at both the same time, but the question don't want to let us know the answer. That's why they're doing it. So right at this place, as you can see right now, it is 2 to 5. So if I pick out the maximum value, it comes out to be 5. So although I did two operation, the maximum value comes out to be 5. But on another universe where there is another possibility, if we try to pick the maximum value out of it, it comes out to be 3. So we did the same number of operation, but it found out that this is the possible case in which this question also had mentioned, although there are multiple cases, but this is one of the case in which we found out that this is the minimum value out of all of these. These out of these, this is the maximum value, but out of all the possibilities, this is the minimum value. That's the question want us to know. So is that's pretty much it. So I'm gonna explain you how to solve this question. So there is lot of ways, brute force ways, but I found a solution which it's kind of intuitive. It's really straightforward. So we just need to just look at this formula: seal element slash answer minus one. So what this kind of operation, the formula want us to do. Bro, let me just rewrite it again. It's kind of looking really bad. Wait. So here I'm back again. So this is pretty much the formula which we can use to solve this question. So first of all, we know we are for sure that answer is obviously going to be less than or equal to 9, since this is the maximum value which we can get. You have guessed it already. Obviously, when just consider, man, we obviously know that the answer is always going to be less than equal to 9. And there is one more case in which basically answer is always going to be 1. It's obvious. There is a bag with no balls, basically doesn't make any sense. If I do this 0, what does it mean? So that's why answer is always going to be belongs to set of 1 comma 9. Yeah, that's pretty much it. So let's get back to the solution. So here we got this amazing formula. We can use this formula and simply find out the answer. So let's say, as I just told you, the answer could be in the set of this. Let's say the maximum value out of these is basically 8. So the possibility of answers could lie between in this array, basically the numbers which is less than equal to 8. It could be 7, 6. Basically you guessed it. So let's say I try to do a linear search and start from here. Since I thought we want the minimum value, so why shouldn't we start from the minimum value itself? So let's say I pick 1, and I did this operation right at this place, which is element basically means the each element of this array. So let's say it's 2 and answer is 1. So if I do 2 divided by 1, so basically comes out to be 2. And if I do seal of it, it's obviously 2 since we have no point value in it. And if I do minus 1, then it become 1. Then after that, we got 4. If we try to do by 4 by 1, it's 4. And if we do seal of 4, it's still 4. And we're going to be 3. You guys just write the pattern. It's going to be 7 and it's going to be 3. So, guys, as you observed, right, after summing up the operations, right, at this place, after doing operation in these elements of bags of array. So, what we found out that the sum of it comes out to be kind of 11. And according to quotient, the maximum operations we can perform is 4. So as you can guess it right, it's getting, exceeding the limit. So it will going to divide the number of array, number of element into more than expected. So it's going to take 11 operation, but our maximum limit or threshold is basically 4. So we can't do this one. This one could not be the answer. So we then move on to 2. It's kind of brute force way. Anyway, since we're going to do it, but I'm going to show you the efficient one after this linear search which we're going to perform. So once we got it 2, so in 2 simply we're going to put the values, then 2 divided by 2 is 1, and then 1 minus 0 and 0. Then after that, what we got 2 divided by 4 is basically 2, and 2 minus 1 is 3. Yeah, then after that 8, then 8 is 4, and in 4 minus 1 is 3. So right at this place, what we found out that, it's pretty good. It's 2 and 2. It's basically here it is 1. I did the wrong calculation. It's going to be 1. And then after that, it's 3. Then once we got over here 2 again, it's 0. So if I do a sum of all these operations, it still comes out to be 4. So this could be a possible answer. So do we need to go to the 3? I mean, guys, I mean, aren't you dumb? I mean, we already know that we're gonna find the minimum value, and that's gonna be our answer. So why should we move on to three anyways? So that's pretty much it. That's the whole concept behind it. And right at this place, we are doing a linear operation. So I mean, I'm gonna tell you what's wrong in this kind of linear operation which we're gonna perform. So let's just code this thing up. So I'm gonna basically create a function called can solve. I mean, whatever you want to say. Then we're gonna pick out an answer. I mean, we know that the array of answers is basically lies less than the number of maximum number out of the nums. So what we can do basically, we're gonna pick out the operations we have performed right now. I mean, it's zero. Obviously, we're gonna start. Then from the array, we're gonna pick out each element which I've shown you right at this question. Its element, and what we're gonna perform is basically we gonna calculate the number of operations is take to perform. Basically, we're gonna do a seal of it, and then simply going to element divided by answer. And in this way, we're gonna check. I mean, how many operations are required to perform this kind of act the question wants us to do, anyways. And if we found out the operation which we have is kind of greater than the maximum operation which we want, so obviously it's not an answer. I mean, it's getting out of hand. I mean, we want I mean, the maximum operation which we right now have is kind of less, and the operation which we are getting is kind of high. So I mean, it's totally not an answer. Then after that, we're gonna return true since it's have covered all of the cases which I've mentioned in this table already. Then after that, what we can perform is basically I'm gonna do a for loop like I've said, and in which I know that I is gonna be in the range of 1 comma what do we say, maximum value of the nums which I mentioned, and plus 1 since I want to include that number. Then after that, I'm gonna check. I mean, if can solve this, I can solve this could be a possible answer. If there is that possible, then it's I mean, it's I obviously. So let me just run it for you guys, and hopefully this thing will work. I mean, I'm just guessing it would work. Okay, so there's one more thing. I mean, it's not num, it's nums. So let me just run it. So I mean, it should work, right? I mean, it's working in the test case, it must work in that case also. Okay, let's just check. Hmm, maybe there is a time limit exit. I mean, I have already spoiled the question for you, but anyways, there is one more catch. I mean, in the hint they have given that we need to perform a binary search, which basically means that the question answer, I mean, the solution which we have is kind of O of n square since we are doing two linear operations and in a loop, but it could be O of n log n. I mean, we can do that. For that, you have guessed it right. Instead of doing linear search to get the possibilities of answers, we can do a binary search, and that's how we get it. I mean, yeah, that's pretty much it. So I'm gonna say left, comma right. So left is obviously that starts with zero. I mean, it's one since we know that zero is not going to be answered anyway. So and after that, we're gonna pick num as max one. Then after that, I'm gonna do a while loop as a standard of L is less than R. Then if I'm gonna say I'm gonna first of all I'm gonna calculate the mid value. It's obvious formula that it is R plus L and then divided by 2. I mean, not right this place, I write at this place. Then after that, what I'm going to do is basically can solve function which I've just created. I don't know how it works. I mean, I've just told you, but let's just plain that way. Then I'm going to be like this. Then I'm going to tell you why I picked R equals to M and not and L equals to M plus 1, and why I'm so sure that our answer basically is L. So if I try to run this code, I hopefully think that it will work since I just performed the binary search, although it is kind of okay, it's again nums, bro. Why I keep writing num again and again? Anyways, guys. So yeah, it is. That's it. I mean, we just perform a binary operation. So what I'm going to tell you guys is basically this left pointer is just moving to the right direction since we know that our answer is bigger. And in this case, we just found out that the answer is possible. So it is possible that we can go to left side to get our minimum value. So we just chasing to the towards left to get the minimum value. That's why I'm using this. If we are not able to find it, it's obvious that our value is kind of bigger. So that's pretty much it. And if I try to submit it, and this thing will work. And yeah, that's how we do it.